Okay, hello. Yeah, hi. We'll just wait for another 1 minute and then I'll start, okay?
Yeah, sure.
Okay. Okay, let's start then. Hello, everyone. Good evening.
Good
Hope all of
evening,
you are
ma'am.
doing good. Yeah, good
Yeah.
evening, all of you. Okay, okay. So let me first talk about what we could complete so far. Okay, we did all the networking devices. We understood the installation of packet tracer, and we did some simulation of client server model. And briefly, we have understood what is OSI and TCP/IP model, a 7-layer OSI model and a 5-layer TCP/IP protocol suite. Okay. Today, I will talk about a little about 2-tier, 3-tier, and spine leaf architecture, and something related to LAN, WAN, MAN, and a bit of IPv4 addressing. Okay, so today the class is going to be a bit short, okay, since I got some urgent work today. Before that, I have some sort of, just to start about, I just want to know how some questions, like few answers from like the given question. Okay, let's say I ask you question number 3. I hope my screen is visible to everyone. So you can just let me know through chat box the answer for question 3. Acknowledgement, sequency, and flow control are characteristics of which layer? Come on, guys. Quickly tell me if you have attended the lectures seriously, then you should be able to tell me the answers. Yes? Very good. People are saying option number 4, which is layer 7. That's really good. That's really good. That is transport layer. That's nice. Okay. Uh, that's nice. Now let's go to the question number, let's say 7. When the data is encapsulated, that's good, guys. That's really a good response, which I'm seeing from everyone. Question number 7. Let's go to question number 7. When the data is encapsulated, which is the correct order? When it is encapsulated, okay, that means it's going from the top to the bottom, from application layer towards the physical layer. Okay, Ayushi says option D, Naresh says option C. Okay, they all look very alike. Okay, guys, so just check out properly what you're saying. Okay, Kaustubh says C. Few are again saying some are saying D. Okay, so majority I see people see are giving me answers option C. Okay, so first is data, then comes the transport layer where we see it is known as segment. Then comes the network layer, which is nothing but packet. Then comes the frame, and then comes the bit. Okay, so very good. Option number C is the correct answer. Okay, please remember the layered architecture just for the sake, like we have application, presentation, session, transport, network, data, and physical layer. So we can make some sort of, and some sort of acronym or some sort of mnemonic out of this to understand which layer we are talking about. We cannot just shuffle it. Okay, layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, and layer 7. Okay, so option C is my correct answer. Okay, let's go with the option 8, question 8. If you use either telnet or FTP, which is the highest layer you're using to transmit the data? Okay, what do you think? When you are using telnet or FTP. Now, telnet is a remote application. We have not discussed so much, but when we were talking about the services, we were trying to talk about this various services which are there. Okay, Omkar says layer 7. Very good. Option D, that's right. So layer 7 is the application layer. So all these are the application services. Very good. Very good. So you all are able to tell me, at least you're attending very sincerely. One last question we'll take now. Which protocol is used to find the hardware address of a local device? Now, this was the question which was asked by one of the student in the previous class, and I answered it very shortly because I was supposed to cover this topic. Okay, the protocol used to find the hardware address. Okay, I generally know the IP addresses. Now I want to find the hardware addresses. Okay, so Abhishek is saying ARP. Most of you are saying option A, but not majority. Yeah, okay, okay. So yes, it's ARP. Asal, it is not ICMP, okay? It's ARP protocol. Okay, ICMP is a used for checking the connectivity or to check the network layer status. It's the ICMP. Okay, it's the ARP. Sorry, it's the ARP, Address Resolution Protocol, where we have a table which maps the IP address with the MAC address. Okay. Yes, Roman, you're right. Correct. So we have such question answer sessions every day before we start, okay? So that we also get to know whether you people are understanding whatever I am teaching. Okay, so I guess everyone is going good. So let's get back to today's agenda, what we are going to learn. Okay, so starting with the concept of we have this concept of bandwidth. Now this was also something which I tried discussing in the previous class about bits and bytes. So this is one of the very crucial parameter in the network. Okay, we are always requiring a good sufficient bandwidth so that we get a good quality of experience or a good quality of service, because these are the two other parameters which generally we are interested to calculate: the quality of experience, the quality of service. There should be no latency, all this, there should be no delay, and the bandwidth should be as high whatever is this the underlying technology whichever we are using. So accordingly the bandwidth should be available to us. So it's a very very important parameter. It's not available for free. We are paying for it, and it's very critical for the network performances. We know how it is being measured in terms of bits per second, kilobits per second, megabits per second, gigabits per second. So it's bits per second. Now, as I was trying to discuss about the three-tier or the two-tier architecture in the previous class, I just thought let me give you a very quick overview about LAN, WAN, and MAN so that we have a clear picture, because generally we don't understand a basic way of under defining what is a LAN or a WAN or a MAN. So I just put down the very simple term that if we have two computers in our home or in our room or in our entire building or in our entire campus, and we want to connect them, so we say that we are connecting them over a local area network. Okay, so very quick and simple definition: two or more computers or any devices, because it is not necessary we have computers here in place. We may have switches also. So any nodes, okay, two or more nodes, a simple term I can say is nodes, that are in a room, on a floor, in a building, or in a campus. If they are connected on LAN. Okay, some of the features will talk about land, that who is the owner of the land, what is the cost of deploying the land, what are the equipments or the components required for the land. So these are the characteristics of the land. Okay, that we are supposed to get a very high bandwidth, high speed, high capacity when we are deploying a LAN. Okay, and whoever is the owner of that premises, like for example, when you are setting up a LAN at home or in your organization, in your company, wherever, owner of the premises is the owner of the LAN. Okay, so since we are not taking help or we are not purchasing it someone from some service provider, okay, we are not going to any service provider to come and design a land for us. Okay, so the owner is itself the owner of the premises itself is the owner of the land. And very important thing what we require is that when we deploy the land, the cost of deployment should be very cheap, the equipment should be very compact and should be powerful enough to provide you high bandwidth, high speed and high capacity. And the maximum size of the campus can be defined as the size of your land, which is your campus wide land. So more or less we try to say that we are designing a campus network. Okay, most of the time when we say that a campus network has to be designed or an enterprise network has to be designed, so what is this? Okay, basically we are trying to design a LAN only. Okay, we are trying to design a LAN. Okay, however, when we go on connecting to of our branch offices, which are not in the same which are not very close which are not at a very close proximity, or which are separated at a very a little, I can say, geographically separated, but they are in the same city or they are not in the same city, then we move on towards a different approach, which is your man and van. Okay, so again, we'll understand the characteristics of a man and van. The definition will almost remain the same with a little modification. Okay, so that you all can remember it very properly. It's the same thing, but now we are saying that they are geographically separated. Now this is metropolitan area network. We don't talk about this much. We either go with the LAN or a WAN network. So this is like within the same metro city, but geographically separated, then they are said to be man. And van has to be what? It has to be geographically separated, but not within the same city. So that is the definition of a van. So this is the general definitions of LAN, WAN, man. Since we studied or we just saw the characteristic of LAN, that it should have just three important things. What we could identify from here, that we should get very high bandwidth over a LAN. The owner of the premises is the owner of the LAN, and the cost of deploying is cheap. These are the three features of a LAN. Now, on the same line, we'll understand what are the features of MAN and WAN. Okay, so let's discuss that first. So here comes the characteristics of a man and a WAN. Now I have clubbed it together since I have to, they are not much different geographically within the same city, but they are geographically separated. Okay, that is something which is important. Within the city or beyond the city, that is how that makes a difference. So now we cannot say that we'll have a very high bandwidth over a man or a WAN network. Okay, it typically depends on what kind of service you're running. Okay, what kind of service you want, and based on that you decide what kind of bandwidth needs to be you calculate your bandwidth requirement, and accordingly you set up the link. Okay, so we can say that we can have high to moderate bandwidth interconnectivity, since the cost is one of the very important factor when you go and purchase a link. Okay, when you go and purchase a link from the service provider, so the cost factor comes over here. So accordingly you try to compromise, or you try to see what kind of investment you can make. Owner is, again, owner of the premises is the owner of man and van. If it is my organization, which and I have several branch offices, then the the cost of whatever, I can have my own equipments. Okay, owner, now see, it is completely dependent on me whether I can have my own equipments, components which I can use, and I can just purchase the link. Okay, the bandwidth what I'm talking about, or I can have that both, everything, the link as well as the equipments, whatever is required to build a network can be provided by somebody else. That is your service providers. So mostly we say that if I am building my own man or a WAN network, I am the owner of that particular premises, where links are leased from the service provider. The cost of deploying is very high as links are leased from service provider and the customer premises equipment can be leased or owned by the owner of the premises. Okay, it's just like when you go and purchase a 2 GB link or a 3 GB link or a 5 GB link, you sign an agreement. Okay, we say it as an SLA. Okay, that is a lease agreement we sign so that we say that we are running so and so services. For example, I'm a bank organization. Okay, I just take an example that our organization is a bank. Okay, now we will try to understand what services the bank does mostly, because more or less we are dealing with three types of services. Generally we have a data service, we have a voice service, we have a video service. I don't think so any other thing people. Okay, these are the different three services which we have. Okay, so can you people just tell me through chat which of the services will a bank require more? Cost of says
Data.
data. That's
Data.
all right. That's right.
Data service.
This is that's right. Maximum, okay. If I see even voice is required, that's right. But maximum we would require a data service, followed by if I have to organize some conference meeting with my colleagues or with somebody who is in other branch or in my headquarters, then I would definitely require to have a voice conferencing or a video conferencing. But the amount of those services which I would use would be very less as compared to the data services. So based on that, I will calculate, like, for data how much of bandwidth I need, for voice how much of bandwidth I would require, for video how much of bandwidth of I would require, and then I'll make a total calculation that okay, this is something which I figure it out that this is my requirement. Okay, so based on that, because every services, okay, every services has something, like for example, when I say that I'm using a video service, so I know what is the maximum like size of the file. So accordingly, the size of the file and the calculation we can do in terms of bandwidth, that according to one frame or one video file or one voice, how can we calculate the basic unit of the data, voice and video is known to us. So based on that, we can do some calculations. I'll show you something interesting related to this maybe in tomorrow's class. So these are the services which we have. So based on that, the bank has to calculate and then, go to the service provider or check with the service provider that this is what is my requirement. And then, you can get quotations that these are the links what we provide and this is the service what I will give you. I will ensure that your links are up for so and so many time, because you need the services to be highly available to you, highly reliable. The service whatever or the links which you are purchasing, okay, the agreement says that we are going to give you so much of some support, like 99% times or 99.99% of time all your services will be available, there will be no downtime. So 0.001 whatever they are saying the downtime, accordingly we sign up an agreement, and if that particular thing they fail to achieve that objective or that availability whatever they have said, then they got to bear the cost. Okay, so yeah, that's right, SLAs. So here in those terms only we are talking. So that is why I said the cost of deploying the land is very man and van is very high, and it's like totally dependent on your service whatever you are running according to that. So services of your network defines the architecture of network, that is what I just said. And the next generation man WAN network, it uses a converged architecture. It should be capable of providing video voice services over a converged architecture. That means we don't lay down a different network for a data service, for a voice service, or for a video service. We are architecting a network so that all the services can utilize the same architecture. So that is what is the next generation converged architecture. So converged meaning it says itself that you are trying to take up all the three services over one single architecture. Now the administrative control of a man can be centralized or a distributed. The control, it means what? Like whom should you approach when there is a kind of failure or there is some sort of uh, the system has got crash or something, if anything happens, so who is going to control? Okay, it's like the control is given. Okay, either it can be a centralized manner or it can be in a distributed manner. Now for a WAN, it is obviously it is required that you need a distributed approach. You cannot have one centralized approach. Okay, you need a distributed approach. Just for an example, if something happens in your bank, okay, you go to a bank, or there's some services which is not available, so whom do you approach next? Do you directly go and approach to the headquarters of the bank, or you directly try to approach somebody who can, give you the solution for that? So accordingly, there is a distributed approach which is followed over a van, or and in a man it can be distributed or centralized based on the mission criticality, that what kind of services or what is running based on that. So I hope now you all have understood what is LAN, WAN, MAN, because this is very important when we are designing a network. So accordingly, the kind of structure, okay, now the 2 tier and the 3 tier, let's come on to that, because now since we have understood what is LAN, WAN, and MAN, I'll just discuss about the 2 tier, 3 tier architecture. Okay, now that's okay. So I hope the packet tracer is visible to everyone. Is it visible, guys? Okay, okay, that's cool. So now what I see here, I have just drawn the architecture for y'all. Okay, that is, we have a 3 tier architecture on my left side, and spine leaf architecture on my right side. There is obviously one more thing, which we have a 2 tier architecture. So starting from the bottom line, okay, of a 3 tier architecture, so we see that uh, I have three kinds of systems. Okay, I have two desktops and then two laptops and again two desktops. Now these are nothing but, these are our end devices or our end points. Okay, so I can have any devices. I can have a wireless communication. I can also have a wired communication. Now, these are the devices which are connected on the first layer of switches, which are known as the access layer switches. Okay, so the switches which I have taken, which is a 2960 switch. So if you can see that all these switches will be considered as a layer 2 switches, and they are known as the access layer switches. Okay, so what is the job of the access layer switches? The job of the access layer switches is to provide connectivity to all the end devices. So all my end devices are going to come and connect to this layer of switches. So what is the requirement now? What do you think is the requirement when you have a layer 2 switch or an access layer switch? Because you just need to connect, or you need to serve all the users, because all users are going to connect to you. So what is one of the important requirement when you want a layer 2 switch or an access layer switch? Anybody who can guess? What would be one of the important requirement if I have to connect hundreds and thousands of users? Okay, and all those users are connected on this access layer switch. So one of the important requirement of the switch is going to be what? It should be what? Anybody who can guess? Your voice is breaking. Whoever is saying, your voice is breaking. Okay, you can mention through the chat. I guess I could not hear you clearly.
Could you please repeat again?
My question is that since I said that I am connecting all my end devices over a layer 2 switch or an access layer switch, which is generally where all end devices are connected. So what would be one of the requirement of those L2 switches or access layer switches?
It should have a connection to the layer 3 switches capable
That's
of connecting to layer.
that's important. And what else? What is something more important? Because if you have more and more
So
of
it's ports.
users, yes, you should have a good density, port density, we say. You should have good number of ports. So accordingly, the one of the requirement is that your ports which you have, the port density should be sufficient enough to connect all the users, the bandwidth. Okay. Since somebody said that, okay, now at the one side you are connecting the end devices, at the other side you are connecting to the distribution layer. Now why do you need that switch? Okay, and we say that distribution layer switch, which is above the access layer switch, which we say it again as a layer 2. Okay, now why do we need that switch? When we have to communicate, let's say PC0 wants to communicate with PC2, which is just aside of that, Do you think the distribution layer switch has any role to play? It doesn't have any role to play, right?
Yes.
Right or no? It doesn't have any role because they are in the same, they're connected on the same switch. So when they want to communicate, they can directly talk with each other with the help of access layer switch. But let's say I want to connect with PC 3, or I want to connect with laptop 0 or a laptop 1, then my access, since there is no connection between the access layer switches, this is something very important you have to understand, that the first layer, okay, since it is known as 3 tier, this is known as the layer 1, okay, where my access layer switches is there. Okay, so here you can see that in this layer switches, they are not interconnected with each other. Okay, they are like acting like a separate, like you have to consider that you are designing a network, or you're designing a LAN to connect two buildings, or to connect the flows inside your own building. So accordingly, when you want to connect to a laptop or a PC or a user who is sitting somewhere else, okay, who is sitting on some other switch, okay, some other access layer switch, then you need somebody to communicate. So that person, that switch is going to be your distribution layer switches. So all the distribution layer switches, you will see that there is a kind of mesh connection. All access layer switches have access to all the distribution layer switches. There is a connection going from this particular PC, this switch to this one, this to this one. So this is a kind of mesh connection, which we say that every this access switch has a connection to all the other distribution switches, so that we can talk to any of the host or any of the user who is sitting somewhere else. Okay, so that is why this switches, okay, now whichever we are connecting to the distribution layer switches, now this is going to be your the ports which we say, okay, the ports whichever is connected to the distribution link layer, we say they are uplinks, and they need a good bandwidth. Okay, there has to be a good bandwidth, okay, to be supported, so that your traffic can be taken up properly. One thing which you will observe here, okay, I want you to observe this thing, that there are some green links and there are some red or orange, what you can say, those types of connections you can see here. Okay, now those connections are blocked connection, whichever you see as uh, orange color, okay, wherever you see an orange color link, it's basically a blocked connection. Because we'll learn sometime later about spanning tree protocol, that whenever we connect switches and if there is a kind of looping which happens, okay, we'll come to this in detail. Just to give you one quick overview, that whenever we connect switches and if there is a kind of looping which happens, in order to make the thing loop free, we have a spanning tree protocol. So as soon as you connect all, I have not configured anything in these switches, okay, I've just placed them and I've just connected them with the help of cables. So even you can go and try this. Okay, just pick up the computers, the switches 2960 for your access layer and all the multi-layer switches for your distribution and core, and just place them and connect them. You will find that they will take some time to turn green or to come up. Okay, in technical way we say to come up. Okay, so that time, of some time later, you will see that not all the links or not all the ports are going green. Okay, they some turn out to be orange, and that is because the spanning tree protocol was running and it identified that there was something loop which was forming. So by blocking one of the port, it has made the loop free connection. Okay, and we are going to understand that how it makes the loop free connection and what happens if there is a loop. Okay, what is the drawback of having a loop, and what is, how do we avoid it? Okay, so spanning tree protocol helps you avoid a looping. So what happens over here now, since you are trying to connect, okay, you are trying to connect all your access layer switches to all the distribution layer switches. Okay, there is a possibility that here from layer to layer 1 to layer 2, or from access to distribution layer, all your links may not be up. Okay, because due to this loops, okay, you may have a possibility that some of the port may be blocked. So one thing what you see is that you cannot get high amount of bandwidth. So all you're connecting 3 4 links in this direction. Okay, and if any of loop is being formed, so that particular connection will be blocked, so you're not getting high bandwidth. That is something which I want to say. Okay, so you will not get a high bandwidth when you are trying to, try to get your traffic passed through the distribution layer switches. This is required distribution layer, so it is aggregating. One of the other term which is used is it is aggregating all the access layer switches, and then it is trying to forward your traffic based on whatever you want to communicate with the other one. So here you need a sort of routing also. Okay, that is why we have a multi-layer switches. We cannot just do with the help of layer 2 switch, because layer 2 switch, the requirement is just to be a little cheaper, because you want to connect all the end devices, thousands of users. You need good ports with good bandwidth, which it should have for connecting towards the user, as well as to connect to the distribution layer switches. So based on that, you connect any model like 2950, 2960. You can use any of this for access layer switches. But when you move towards the distribution layer switches, since you want to communicate to the computers which are on different access layer switches, so you need that there has to be a routing also, which will come into picture. Okay, routing will come into picture, switching will come into picture, because they may be on different networks. It is not necessary that this particular PC and this PC are on the same network. So you would need routing as well as switching. So you make use of the layer 3 switches, or I can simply say the catalyst switches. 3550, 3560, these are the models which are used. So again, the requirement of distribution layer switches tends to be like the features it requires is it requires a good bandwidth. It requires a good bandwidth so that it can uh, forward the packet. As soon as it receives from that, it can just take the decision of forwarding the packet to the correct access layer. So it requires good processor, all these things. Now again, you will require something which is, if you want to communicate between the different distribution switches. Now I have 3 distribution switches in my place. Let me just remove this labeling which I was showing there. Now it seems a bit better. Okay, so now when I want to communicate, okay, now if I have, you can see that I have 3 distribution switches. Now if I want to commit, so 1 and 2 are also interconnected, 2 and 3 are also interconnected. Now why do you need so many distribution switches? You will have to think. There is a sort of redundancy which we have kept. Okay, when we are designing a network, we want that they should be highly available. This is one of the very important requirement, guys, that you need the network to be highly available. Okay, there should not be much of downtime. And in order to achieve this objective of highly available, you ensure to keep redundancy in your network. Okay, you ensure to keep a redundancy in your network, so that if any time one of the switches, so if this distribution layer switch fails, still my packet or my traffic can be routed via different distribution layer switches. So you see that there is a redundancy in the distribution layer. However, I've kept one core layer switch. Now coming back to the core layer, because if you have to connect, or if the traffic has to be routed between 2 distribution layer switches, then you need a core layer, which is the backbone. Okay, this is the backbone of your entire network, of your campus. Okay, your 2 buildings, you can assume that there are 2 buildings, you're developing a LAN for, designing a LAN for that. So your core layer switches are connecting those 2 LANs, your 2 LAN segments, 2 or more LANs. Okay, so your core is going to just give you high bandwidth. Okay, it's the backbone of the layer. It is not supposed to take any kind, it is not going to do any kind of manipulation. It is just be involved in forwarding the packet at a higher bandwidth. Okay, so the job of the core layer is to give you good band. The switching has to be very fast, and it also uses routing protocol to route your packets. So majorly you can say that to connect the access layers, you need the distribution layers, and to connect the distribution layers, you need the core layer. Okay, and there is a redundancy at the core layer, there is a redundancy at the distribution layer. When I talk about redundancy, you can see that when the traffic from this layer to this switch doesn't go, if it fails due to any reason, then this distribution switch can take care of it, because I have a redundancy. I have kept a redundancy. I have kept a redundant link. Okay, and I have made it in a full mesh connection, so my traffic can be taken up properly by another switch. Okay, so redundancy is observed in the distribution layer. It is also observed. So I have to place one more core layer switch so that if this core switch fails, just understand that if you just have one core layer switch and if that fails, then your entire communication will be halted. Okay, so this is very important that you see a three-tier architecture or a hierarchical architecture, because initially when the system came up, okay, when you can say that 2 or 3 decades before, when before this structure came up, okay, people used to just randomly try to connect all the, the network was not that specific, the architecture was not very specific. It was like, okay, you take one switch and you connect now all the devices to one switch, but now when the requirement goes more, then you take another switch, then you take some users there, some users here, connect the two switches. What now if more requirements come, then how to connect the third switch or the fourth switch or the fifth switch? So there was some sort of, there was not a kind of proper organized way of architecting the network. So this was the three-tier architecture or the campus network design which we used to follow. Okay, so that we see a proper structure, we see that the proper traffic, okay, there is a clean and neat way of understanding how the packets will get forwarded, how it will get routed, and it also helps you scale. Okay, when you see that now if I have to add more of my access layer switches or distribution layer switches, so the scalability is also quite good. Okay, now what is the problem over here is that you see that first and foremost the bandwidth requirement, okay, the bandwidth, whichever, since you have a redundancy link, you see there is a sort of loop which is being formed. Now we are going to come up across loop, what is a loop. As of now, you just understand that you see whatever, wherever you see the orange link, okay, wherever you see the orange link, that means those links are being blocked, they are not participating in communication. At present they are being blocked because there was a loop which was formed, and because of that the link is being blocked. Now since the link is being blocked, you don't get the required bandwidth. Okay, when you suppose if you have 4 links which is going out of that thing, and if one of, so each port is supporting you 10, let's say 10 gbps of speed, each port is giving you. Okay, each port, if from every switch, if there are 4 links which are coming out of it, and each link or each port is of 10 gbps, so total I should be getting a 40 gbps of bandwidth to route my traffic. Okay, however, if one or two of them gets blocked because of the loop technology or the loop thing which happens, so what happens is the amount of bandwidth which I get will be reduced. That is so simple to calculate. If one of the port gets blocked, I'll get 30 gbps. If two gets blocked, I'll get 20 gbps. So likewise, because of spanning tree, what was happening here, that the amount of bandwidth was not up to the mark what was required. Now, for that, people went on to the other concepts like ether channel, which again we are going to learn how to overcome this kind of scenario where you see that the amount of bandwidth utilization is not good due to the spanning tree protocol, which has blocked due to make it loop free. Okay, so there are some other ways, other methods to overcome that. But at present, you can see that okay, I am not able to get all the required bandwidth which I should be getting for my traffic. The second thing what you see is that if a packet has to go from PC0 to any of the PC here, okay, let's say here is my PC0 and to here is my PC1. So if a packet has to go or a traffic has to go over here, it has to first go to the access, then to the distribution layer. From the distribution layer, since now this is not directly connected, okay, however, if you want, you can actually send your traffic. If it is not blocked, you can actually send it to this distribution layer switch. From there it will go to this access layer and then come to this PC. So there is a kind of, a kind of latency will be involved because you are hopping your packet from the access to the distribution, from the distribution back to the now since I'm using this distribution layer, so you see there is not much. But if I have to go from the distribution then to the core, and then from core to distribution, from then distribution to access, so you can see if I take this way, okay, from this access to distribution to core, then back to the distribution, then to the access, and then coming back, so there will be a lot of latency involved in such a scenario. So there were two disadvantages. There are many more, but first, as of now, these are the two disadvantages of this three-tier architecture. Now people went on to the two-tier architecture by just collapsing the core. Means if I just remove this core, okay, let me just clear this drawing. If I just collapse, if I just,
Ma'am,
yeah.
why we are not going to the switch multi-layer switch 1 to directly to the switch PC 1?
We can go that way, but let's say this link gets max. I'm guessing the worst case. Let's say now there
Okay.
is the worst case. Now this link, this particular switch has got the switch has failed, or some link has gone down. Okay,
Oh, okay,
some of the
okay.
link may go up and down. Now we are not connecting, we are considering this year as a very simple design, but in a real time scenario, we know that there are thousands of users, thousands of hosts, and you are trying to build such kind of hierarchical model. Okay, so
Okay, okay.
in that case, I'm just trying to see that what could be the latency involved. And secondly, what I was saying here, that if their people also went on to a two-tier architecture. Now, two-tier architecture, also known as the core collapsed or a collapsed core architecture, whereby I just remove this and I make this itself as my core as well as the distribution layer switch. So when should you go for a two-tier or a three-tier? If you have a very small campus, if you want to design a very small campus network, then definitely you will not go towards the core layer. Just understand one thing, guys, that when we are talking about access layer, distribution layer, or core layer switches, their switches are very, very expensive because they are going to give you good bandwidth. They are going to support both routing as well as switching, the distribution as well as the core layer switches. So they are not very cheap as what you get the access layer switches. So if you feel that your network design is very small, then we better go for a two-tier architecture where the collapse and the core and the distribution, they acting like the same. Okay, and then coming back, so people used to follow this network design, two-tier and three-tier, way lot. Okay, however, now some scenario has changed because of the spine leaf architecture. Now the spine leaf architecture is majorly useful if you are going for a data center. Okay, now anybody who knows what is a data center? Anyone who just can let me know what is a data center? Have you heard about this term, data center? Yeah.
Where all the information is hosted.
Information is hosted in the form of what?
All the datas or physically hard
In
drive and
TVs.
everything.
It's
Can we tell?
it's
Can we say that?
well secured premises area where all the devices, maybe computers, servers, storage, network
Right,
devices,
right,
everything is
right, right, right. So it's just housing all your servers, computing devices, storage servers, computing servers, your networking, your switches, routers. So all, it can be just one entire building or it can be just one small room. Okay, so that is what we say, that it is just a housing of all your servers and networking components. Okay, so all the facility is being arranged in such a manner that your data mobility happens at a very good bandwidth. All the applications are running properly. So we normally used to have in the data center this kind of three-tier approach previously, but now we have moved on to the spine leaf architecture. Why? Because, for example, now if I am sitting over here and I'm trying to put a request on a website, so what happens is, uh, here I'm sitting, I put a request to the server. Okay, now this server is basically going to be my web server, let's say. Now what it is going to do, it is being attached from the back end to the database. Okay, so as I put a request, it fetches the data and then takes it and forwards it to the client. Now what happens is, most of the time the traffic flow, here what you see, that the traffic flow from was from south to north. Okay, in order for this PC to communicate with this PC, we had to go via such kind of approach or via this kind of approach, any approach you take. So it was moving from south to north approach in order to reach to this PC. Now in a data center where we say that majority of our end devices are going to be servers, okay, as we see in our campus we have these computers or our host. In a data center it will be majority of the times what you see, what you will see that you will connect the servers or the databases or your WAN network towards your, like, it will be, servers are going to be your end devices, I can simply say. Okay, they are going to be your end devices. So majorly the traffic flow is in the east west direction. Okay, the traffic flow is not in the north south or south north direction. I can simply say that the traffic flow, okay, if this server wants to communicate to this server, so there is a east west flow of traffic which was analyzed by the people, that the traffic is mostly east west direction. So this architecture was developed with that, in that regards, that okay, if maximum, if this server has to communicate to this server, this is my application server, this is my database server, I can have any other server or DNS server or hosting over here. So if I have to speak, I am majorly moving towards east-west direction. So maximum, the architecture is so simple. Then this is known as your spine switches, which is known as your backbone switches, and these are known as your leaf switches. So the connection is pretty simple, that each leaf switches will have a dedicated link towards the spine switches. And you will wonder that okay, here also ma'am you see some sort of, you know, this orange link. So again there will be a kind of bandwidth issue, all your high bandwidth will not be available to you. But we don't use the spanning tree protocol the way I just mentioned over here, that spanning tree protocol is used to make your entire network loop free, because loops can make disaster in the network. Okay, it can just create disaster in your network. So in order to avoid loops, we had this spanning tree protocol. Now what are loops? I know some of you might be wondering, yeah ma'am, what is she talking about loops? So I'll discuss about that, don't worry. But just understand that when you are connecting the two devices and if there is a loop formed, okay, so there is going to be some issue, and that is being avoided by the spanning tree protocol. However, in spine leaf architecture, we are not dealing with the spanning tree protocol. We deal with something else which is known as trill. Okay, now what is that again will be understood later. As of now, you just need to understand that in a spine leaf architecture, we have most of the time the end devices are the end devices are servers. And in order to connect to any other server, I just need to do one hop. I can just reach this server. I can just reach to this spine switch, and then directly to the access switch. Again, from this I can, so there is the latency involved would be very low, and the scalability. So see, what are we interested in when we are designing a network? What are the objectives which we have in our mind? The objective is that first and foremost, we should have good bandwidth. High bandwidth should be available. Second objective while designing the network is to have low latency. Okay. The third objective which we generally have is the scalability, that it should be easy to scale your network as per the requirements. So if any server has to be added, I just need to add one spine switch, one access layer, one leaf switch, and then directly make one connection from year to year, and then it is ready to go. Okay, it doesn't require a lot of things to be done. Unlike a 3-tier architecture, it is also good in terms of scalability. However, you can see the kind of mesh connections we have here. So on a counterpart, the spine leaf is very much easier to scale. Okay, so good bandwidth, low latency, scalability, highly availability, all these things you will see. Okay, we need high available networks to be designed, that the downtime is very low. And apart from that, we also need to ensure that we have maintaining good security, we are maintaining good quality of services. All these things are one of the several 5 to 6 parameters which we see when we are designing a campus network or a data center network, whatever we see. Okay, so this architecture is being adopted now, and it's being followed because of the various advantages it has. It is not using the spine tree STP protocol, it uses another type of protocol. Okay, so that all the links, okay, now you can see that there are 4 links, which is 3 links which are going now from this switch 7. The link here is blocked, here is blocked. So now this was a case when we were designing here, okay, like a 3-tier architecture. So only one link is active at this time, though there was 3 links. So it should have, if each port is supporting or each link is giving me 100 mbps of speed, and I could just see that 2 of them are blocked. So I'm, instead of getting 300, I'm only getting 100. So that is known as to be very bad in terms of utilization of bandwidth. Okay, the uplinks has to be very good in terms of support. The uplink, these are known as the uplink ports, and their bandwidth is usually much higher than the normal switch ports. Okay, the uplink ports are supposed to have a higher bandwidth than the other switch ports. Okay, this is something again which I want to tell you. Okay, so I hope you got the basic difference about the 2-tier, 3-tier. This is also known as a traditional architecture. Okay, the 2-tier is just collapsing the core layer, and then this is the spine leaf architecture, where you just, you're in this architecture most of the time. This is there in the architecture is designed for a data center where your end devices are generally the servers. So since we have normally the traffic in the east west direction, so this architecture gives you good scalability. It gives you good like the latency is very low, and hence it is much preferred. Okay, so I hope you people have got the understanding about the traditional architecture as and the spine leaf architecture. All right, so we have achieved that. We have understood that in short. Now coming back to, so we completed LAN WAN MAN, we completed on 2-tier, 3-tier and spine leaf architecture. Now coming back to this on premises and cloud topology, because you're talking about all topologies, on premises and cloud. Yeah.
Yeah, I just wanted to know why east-west, the traffic flow.
Why east west the traffic flows? Okay, so you can see from this diagram. Okay, I'll show you here. Okay, you see that if I have to, this is my application server, let's say. Okay, these are the 3 servers which are now there in my system. Let me clear the diagram. Okay, so we see here that, let's say this is my application server. Okay, this one is my application server, this is my database server. So whenever a request comes from a user, okay, to access the application server, and I have to fetch some data from the database server. Initially, people used to have different servers for different, like for computation purpose, for database, for application. We used to have different servers like. So to fetch that data, I have to move towards this server. Am I right? Okay, so your traffic is going from it wants to move towards the west or towards the east direction, because your servers are being kept in that way, they are being placed in that manner. So your traffic is generally flowing, it wants to access the servers which are placed around that. So you will see that the traffic mostly flows from in the east west direction, so that from your application server can access the database server, some other server can actually access the some other server. So in that manner we say it is east west direction. Here in this architecture, what you see that there was a latency involved because of the south to north. Okay, south to north way the traffic was flowing. Okay, so based on that you see that south to north, okay, because of this approach, the hierarchical 3-tier approach, okay, there was a high latency involved over there as comparison to spine leaf. Now since you see there is no interconnection between the spine switches, there is no interconnection between the leaf switches. So what they have to do is directly they can reach to one specific one of the spine switch and directly access to the other server which is sitting over there. So there is not much of latency you would see here. Maximum one hop or two, maximum one hop which we can say between the two access layer, maximum one hop. However, this was not the case with the 3-tier architecture. Okay, so the east-west direction of the flow is because of the traffic flow, because your servers are laid down in that specific manner, or that arrangement, I can say. So that is why this architecture is much useful, because even if this PC wants to speak to this PC, you see that the direction is not in the horizontal or in a vertical manner. Okay, these are helping us. These devices, networking devices are helping us reach our traffic. But we are communicating, let's say they are on the same layer. We can say they are in the same layer. Layer wise, if I say this is on the same layer, they are on the same layer. So accordingly, the traffic, if it is in the same layer, we can say that east-west is going to be much better approach than the south-north or north-south approach.
Yes.
Right?
Thank you.
Yeah. So yeah. Okay. Any more question, guys? Anyone has any questions to ask here?
Yeah. Can we use L2 as a distribution?
L2 at the distribution? No, that is not possible because L2 layer switches is only responsible for you switching the switching within the computer, like within this network. Okay, within this network, how many ever hosts you are connecting, this will help you out. But if this, okay, somebody is sitting over here, I cannot say they are in the same network, right? Now we are going to learn about VLAN also. So they can be let's say these are all the members of your one of the department in your organization. There are several departments in your organization. So let's say this is my HR department. They are all the HR people sitting here. We have an accounts department who are sitting here. Okay, so if these two people want to communicate with each other, okay, definitely we can directly communicate. If we have a very small network, I can just connect the two switches and make use of VLAN communication. Okay, inter VLAN communication that we are going to learn. Okay, they are in one VLAN and this is in other VLAN. So in order to have an inter VLAN communication, we need to keep also have router in picture. If you have any idea about the VLAN, I don't know if you have any idea about the VLAN.
Okay, yeah. Thank you.
Yeah, we will be discussing about VLAN. So when you want to talk with different VLANs, you will require a router. So as well as in L3, okay, when you take a L3 switches or a multi-layer switches, you can take features from both switching as well as routing.
Okay, we can connect it through the.
Yeah.
Okay, so we can connect it through like inter-VLAN routing, right?
Right. So you need for an inter-VLAN communication, you either require some router on stick method. There are different methods for inter-VLAN communication, or you just place a layer 3 switch and can achieve that job of doing inter-VLAN communication.
Okay, thank you.
Yeah.
Hi, ma'am. Sorry to interrupt. Now,
No issues, yeah.
spine leaf architecture, is it widely used right now in the industry-based?
Yes.
Industrial-wise, I guess.
Right. Yeah, wherever we find the servers, okay, in the server environment, okay, where your end devices are server in, that is why I mentioned data centers. Okay, that in the data center environment, we generally use this architecture. However, when you are developing a very small campus network, then in that manner, we either go for a two-tier architecture. Majority, we go with the two-tier or a three-tier hierarchical architecture.
Okay.
Yeah.
Thank you.
Yeah. Okay.
So,
I was
guys, those spine leaf, which is east to west traffic topology, which is also used in the ACI data center model these days. Okay, and main thing is reduction in the hop counts. Here only there is one hop count between the servers and the core devices, whereas in the traditional there will be two or more hops. So the packet reachability from end to end is very much less than spine leaf. Okay.
Yeah, okay. So I'll just take one last topic at present because I have got some work, but one last topic I would cover here is the on-premises and cloud. Now, these days we are hearing a lot about cloud, and I'm sure you people must have, or must some of you might be working in cloud technology, or must have at least come across this Amazon Web Services, AWS Cloud, or Microsoft Cloud. Anyone, just let me know through chat how many of you have come across this cloud technology. I guess most of you would have.
Yes.
right? So what is the difference, like anybody who knows, like what is the difference of having a on-premise and a cloud technology? Let's say, yeah, Azure. So let's say, for example, you dream to make your own startup, okay, and you want to develop some application, you want to do something, you want to uh, create your own business. Now when you want to create your own business, you definitely need to have a good, kind of, let's say you want to develop a website for it, or and many more thing you want to do it. So initially what people used to do is, if they want to create their own business or develop their own business, they have to think from all dimensions, right, from developing their applications, their softwares, to the point of launching it, and taking looking at it, that how people could how my application is reachable to everyone. So that way networking was one of the important component, that you buy your own servers, you buy your own network routers, your switches, all cables, then you buy the infrastructure to place all your devices, and then you keep a team of people to maintain your devices, configure, do monitoring. So a lot of things was involved when you have to make your own business. However, with the cloud technology now, they have taken all your burdening. Okay, so they have just said that we have all the devices, we have all the servers, we have everything. You can just use it on the rental basis. Okay, you just use our whatever kind of servers you require, how many, the way number of servers, if you require one server, two server, or you require so much of memory for storage, anything, you just take it for rental purpose. That is, you just pay them for the time you utilize those machines. So you need not worry of going and purchasing it and keeping it for the sake of just, if the things are not utilized well, anyways you will your business will collapse. So just utilize it. Try on if you want, if you're experimenting something, don't worry about the infrastructure, you just concentrate on your application, and we will look after whatever you want to, wherever you, whatever services like infrastructure you want, we are going to give you on rental basis, and you just focus on your applications. So that way, for many of the startups, it has become very much convenient, that they don't have to bother about going and purchasing it, and then developing everything from the scratch. So that is the difference between on premises and cloud. Though many of us, in since all of the most of the companies have their on premises network which is already been established, but still again they are trying to also move towards cloud. Okay, they are making use of a hybrid architecture of making use of their environment on premises, as well as developing some of their applications on cloud. But most of the startups, because they cannot take a headache of going and purchasing so expensive equipments, and then keeping people for maintaining it, and if it is not utilized properly, then you will have to take extra attention. So they just go on with the cloud services, they just go and say their requirements and then deploy their applications. So that is the difference between the on premises and the cloud support. Okay, so I end with this. If anyone has any question, I'll take up, and tomorrow we'll discuss the other things which are there in line. Yeah. Okay, if anyone has any question, or guys,
No,
let
all
me
good.
know.
Yeah.
All good? Okay,
Yeah.
so
Thank you.
just in a summarize, we just completed the Spineleaf 2-tier, 3-tier architecture. We understood the difference between on-premises and cloud thing, and the difference between LAN, WAN. So tomorrow we'll start with the IPv4 addressing.
Difference between
Sure.
two-tier
Okay.
and three-tier.
2-tier and 3-tier. In a 2-tier architecture, you collapse your core. Okay, your core and distribution, they are known as a CD layer. Okay, they are one, and they are taking the features of both. So core layer is not there, only the access layer switches, and then the CD switches, we say the core distribution layer switches. That is a 2-tier. And 3-tier, where you have 3 tiers like access layer, distribution layer, and then the core layer. So we saw in the left side the 3-tier architecture because we were having core switches. If I remove the core switches, I can simply say that it is a 2-tier architecture, and that layer which was known before as distribution is now known as core distribution layer. So for a small business environment or for a small campus network, you go with the 2-tier, and for the larger campus, we go with the 3-tier. Okay, guys. So hope you enjoyed the lecture. Go and practice this. Try to make some scenarios like this and see how your connections happens. Definitely, we are going to do most of the configurations for such kind of networks in our future classes. Okay.
Okay.
All right. Good day. Good night.
Thank
Good night.
you.
Thank you,
Yeah.
Sangeeta.
Bye bye.
Good night.
Yeah. Good night.